Alrighty, guys. So our acid was HBr, our base was NaOH. So we said in a neutralization reaction, you always make two different compounds. What are the two compounds made in a neutralization reaction? Yeah, water and the salt, right? So water is H2O. Okay, and we get that because the H is gonna bond with the OH, the hydroxide right here. So these two are gonna make the water. And then our salt is just gonna be the ionic compound that's made, and that's gonna be NaBr. Okay, so hopefully you are able to get that. Okay, and this is already balanced as is, so you guys didn't need to do any additional work. So the products here are H2O and NaBr. Okay, so the next thing you want to do is you want to figure out the molarity of the base that you use to do the titration. And that's going to tell us how many moles of base it took to neutralize the acid. So if you think you can solve this on your own, you can kind of try and go ahead. But I know this is the first time we're going over titration, so I'll go over it step by step, okay? So what was the molarity of this base in this problem? Yeah, if you look at earlier up, right? It tells you that the molarity of the base was 1.5 molarity, okay, and it was NaOH. Okay. Now it says in the problem in step 2 that you want to find out how many moles of base it took to neutralize the acid. If you guys remember, the molarity formula is molarity equals moles over liters, and so we're trying to find moles. So if we rearrange this equation, moles is going to be equal to molarity times liters. And this is how much base that we used. Okay, the liters is your base used. Okay, and we said earlier that the amount of base that you need is just how much you drop from the burette into your flask on the bottom. So how much base in this problem did we drop into the flask underneath? Yeah, 38 milliliters says your initial burette, but when it was at the top, it was at 0. At the bottom, it says 38. So you used 38. Okay, so that's our liters right there. So we had 38 milliliters. Okay, and we get that from right here. Our initial was 0. Our final was 38. So we just do 38 minus 0. And that tells us the amount that we used is 38 milliliters. Okay. So if our initial was like 4 and then our final was like 40, then you would just do 40 minus 4. And so the amount that we use would be 36. But in this case, it's 0 and 38. Nice, easy numbers to use. So we get 38 milliliters. Okay, so take a minute. I'll let you guys work with the person next to you. You have all the numbers that you need. I want you guys to find out how many moles of base you dropped into the flask underneath. Take a minute. Try it out. You can check with your partner. So sorry guys, I know you guys are working on it, but just to show you kind of what the color is going to look like as you add more base. You guys see how it kind of turns pink and back? So eventually you want to add until it permanently turns pink. And that's when you know it's completely neutralized. So I might not actually be able to neutralize it completely. But you guys see how it's going back and forth? You want that pink color to be permanent. Almost there. So it stays longer the closer you get to the neutralization point. But when it gets permanently pink like that, well, I think it's going away. But when it gets permanently pink like that, that's going to be when it's neutralized. Okay, did you guys see that color? That's how you know. So obviously, you're not going to pour it in like I did. You're going to be dropping it from the burette. But that's kind of the color you want to look for. Oh, it's going back. Okay, sorry for the distraction. But there you go. That's the color you want. A little bit lighter than that, but that's kind of when you know that it's neutralized. All right, so take another 30 seconds, figure out the moles, and that'll give you your the moles of base that you added. Alrighty, guys, so let's go over this together. If you're finishing up, you can just check your answer at the end. But we're trying to find moles. If our molarity is 1.5, we can just plug that into the equation right here. This is just 1.5. We have 38 milliliters, but we need to use liters of base. So we just need to move the decimal 3 times to the left, or you can divide it by 1,000. And so that's going to equal 0.038 liters. And so all we need to do is go into our calculator and do 1.5 times 0.038, and that'll give you 0.057. So when we dropped in this problem, we added base into the flask on the bottom. We added 38 milliliters of 1.5 molarity NaOH, but that's the same thing as adding 0.057 moles of NaOH. Okay, so this is the answer for part 2, step 2. Okay, does that make sense, guys? Why we calculated for moles? Okay, we knew the molarity, how concentrated the base was. We know how much base we added, so that tells us how many moles of base we added into the solution. Okay, so now that we have the chemical equation and we have the moles of base, we can calculate the moles of acid. So all we need to do is take our moles of base, so 0.057 moles of NaOH. Again, we just need to do one dimensional analysis fraction. So I'm going to put moles of NaOH on the bottom. I'm going to put moles of acid because that's what we're looking for. So we put moles of HBr on the top. Okay. So if we have moles of acid and moles of base on the same fraction, where do we get the numbers from? Yeah, chemical equation. Whenever you have moles and moles of 2 different chemicals on the same fraction, you get it from the equation. So HBr has no number, NaOH has no number, so it's just 1 to 1. Yay, we don't need to do any math. We just cancel out the moles of base, and so we'll have the same moles of acid in there. Okay, so when we, based on our calculations, we know that we neutralized 0.057 moles of acid, okay, the same as the base. Okay, so I'll write the answer up there. Okay, so we neutralized 0.057 moles of HBr. Okay, so far making sense? I know it's kind of weird, first problem, but we will be doing hopefully 2, maybe probably 1 more problem, and then we'll also talk about it once we do the titration in the lab next time that we meet. Okay, last thing we do is we calculate the molarity of the acid. So again, we said that the molarity formula is moles over liters. Okay, we have our moles of acid, but we need to know the volume of acid. So if you guys go up to the first part of this problem, how much acid was inside of that flask on the bottom of the burette? 200 milliliters, exactly. So if we have 200 milliliters of HBr in the flask, all we need to do is divide the moles of acid by the volume, which is 0.2 liters. And then there you go. You can figure out how concentrated the acid solution is. So that's how you find out the concentration of, or the unknown concentration of an acid using titration. Oops. Okay, so for your final answer, you should get 0.285 molarities molarity HBr. Okay, and that's it. That's a titration problem. The math is not too bad. It's just using the molarity formula and just using one-dimensional analysis step. The hard part is kind of conceptualizing what's going on, because I know it's a lot of different concepts that we're putting together, but that's kind of the fun of chemistry. We just take all these little things and we use it to solve one problem. Okay. Any questions? Clarification? The next problem that we do together kind of helps. Okay, so we're gonna do number 2 together. So what I want you guys to do is, if you're ready to go, just go to number 2 of this handout that you should have up on Canvas right now. I'll leave this up here so you guys can take a look at the steps and kind of what we did just as a guide. And then after that, we'll go over it together. And again, this is being recorded. So if you guys miss something, not a big deal. You can always go back and you'll have this as a reference to look back to. But go ahead now to number 2 of this handout. Just scroll down to the next page. And I want you guys to try figuring out the concentration of the acid in that problem. Okay, it's a little bit different. Because it's not HBr anymore, it's going to be H2SO4, sulfuric acid. So just make sure you guys use the 4 steps and try to figure out the concentration of the acid. Okay. You also need to write procedures for part A, which I'll go over in a few minutes. Go ahead and try that. And feel free to work with the people next to you. Don't mind if you guys collaborate. All right, so hopefully you guys are making some good progress through it. Part A is from last time, the procedures. I'll be going over the procedures in just maybe about a minute, just so you guys are on the right path. And then after that, I'll let you guys finish up on your own. Okay. I'll go over the procedures in just a minute or so. Okay, guys, so if you guys want to check your answers for part A, where you write the procedures, I have the calculations and the steps up there for you. All you have to do is use molarity of the NaOH, and then find the moles of NaOH that you're going to use to make your solution. Use the molar mass, and so what you want to do is you want to add 40 grams of NaOH into your volumetric flask, and then just fill to the line with DI water and stir. So the key things you wanted to add were 40 grams of NaOH, which is how much you need to make your solution. Your volumetric flask has to be the correct size, which is 500. And then you want to use DI water, deionized or distilled water, and fill it up to the line. So this is the procedures you would use. Make sure you guys, if you guys got it correct, good job. If you guys didn't, make sure you guys have this reference somewhere, because this is actually what you're going to be doing in about 10-15 minutes for the first part of the lab. You're going to be making the solution. I'm going to have you guys write the procedures. Okay, so just have this as a reference. It's what we went over last time with the procedures, and this will also probably be on the AP Chem test. Just know that you have to add the solute before you fill it up with water. Okay. You guys a few more minutes to work on parts B and C, and then we'll start going over it. Good morning. Good. Now that I've seen you.
How did it go? Turn out all right?
Yeah. I showed them that it needs to turn pink. Yeah. So I added
You didn't write too much. Oh, you didn't actually titrate one?
no. I just showed them that they drop the base, and then I just added a bunch of base to show them you don't want to make this color, but it's a light version of that.
Do they know that it's all about the base?
I told them you need to drop the base.
Drop the base
Drop the base.
with no trouble.
No. That sounds inappropriate.
I don't even know what the hell that means.
It's
Megan
about,
Trainor song.
yeah, it's about base.
Oh, are you taking the test?
No, they're just trying out the second problem on their own.
So on the video, you pause it.
No, it's just going. Yeah, so they can skip ahead. Alrighty, guys. So I know some of you guys are still working on it, and if you are, you guys can continue to do that. But I'm going to start going over the steps just so that we are all on the same page. Okay, so we had our procedures for making the solution that we're going to use, and so what we're going to do now is we're going to draw a diagram of the titration setup. So we're going to have our flask on the bottom, and then we're going to have our burette on the top. Now, you guys don't need to make the pictures very pretty. I know I'm very artistically talented, as you guys can see right here. But, you know, not everyone is as gifted as me. And so you guys can just do a very simple setup, okay? All right, so where does the acid go? Does it go on the top or on the bottom? Yeah, bottom. Okay, so inside the flask is where you're going to put your acid. And our acid in this situation is sulfuric acid. So we have H2SO4. Okay, what's the volume of acid inside of the flask? How much acid is there? What's the volume? Yeah, 150. It says that there's 150 milliliter sample. So inside of this flask, we have 150 milliliters of sulfuric acid. Now, we said in titration, we're trying to find the concentration of the acid, and so we don't know the concentration. So I'm going to put UNK, UNC, because it's unknown, okay? And the brackets, again, mean concentration. Alrighty, and so what we're going to do is we're going to use the base that you produced here in order to titrate into the acid. So let's talk about the base first. So we know that the sodium hydroxide is inside the burette. It's on the top.
Base goes in the book of the burette. Did you show the so you showed this on the video?
Oh, not on the not on the video.
I was gonna say you saved me a lot of time.
Yeah, I wish I did that. Sorry, Mr. Pepper. I wasn't thinking about you. I feel bad. All right, so our sodium hydroxide is in there. What's the concentration of the sodium hydroxide we're using? Yeah, 2. What we make a 2 milliliter sodium hydroxide base. Okay, and so if you guys look at part C, it kind of tells you the burette reading. So it's telling you, hey, in the beginning you started at 1 milliliter, and then once it's all titrated, it's nice and pink, very light pink. The pink that I have up there is too pink. We want to be like a very slight pink, okay, one that you can barely even see. Okay, and so if we started at 1 and we end at 49, what's the amount of base that we dropped? 48. Wow, you guys are picking up this so fast. Okay, so we use 48 milliliters of base. Okay, so this kind of tells us all the information that we need to do our titration problem. You have unknown acid on the bottom, and then we dropped 48 milliliters of a 2 molarity NaOH solution. Okay, and so now we can start doing our calculation. So I am going to make a little white space so that we can write on this, and then we can start doing our titration calculations. Okay, but before we get started, any questions on this part? Yeah, what's up, great. Sorry, what was that? No, yeah, so it's the reading, and so in this situation, if you look at part C, it's just telling you, hey, when you started, the base level was at 1, and then when it was completely neutralized, when it turned light pink, it ended at 49. So how much did you add? It's just 49 minus 1, and the difference is how much base that you add. So that's the amount of base that you're dropping into the acid. Does that make sense? Okay, so that's where we get the 48 from. Okay, so step 1, we need to write the chemical equation. So let's do that. Step 1, chemical equation. We start with the acid. We have sulfuric acid, H2SO4. And then we have our base, sodium hydroxide. Simple neutralization reaction. We always make water and the salt. And the formula for our salt is Na2SO4. Okay, because SO4 is 2 minus. So you're going to need 2 sodiums to cancel that out. Which means we're going to have to balance this equation as well. There's 2 sodiums here, so we're going to put a 2 right here and a 2 right here, and that's how you should balance your equation. So I know that we're going through a lot of this really quickly, and we're kind of combining a lot of concepts together, and so this is why practice problems are really helpful. Okay, so just make sure that you guys are able to do this on your own, because that'll you'll have to do that on the exam. All right, step 2, you want to figure out how many moles of base you dropped. Okay, we know that the molarity formula is molarity is moles over liters, and so if we rearrange that to find moles, we're going to have moles is equal to molarity times liters. Okay, what is the molarity of the base that we used? 2, yeah, we just get it from right here. We use a 2 molarity base. We used 48 milliliters, which is the same as 0.048 liters. And so if we just want to calculate for moles, we can pull up our calculator. That's going to be 2 times 0.048, and you should get 0.096. Okay, so the amount of base that we dropped 0.096 moles of NaOH. So this is the amount of the moles of base that we used to neutralize the acid. Okay. Step 3, we want to use this to calculate the moles of acid that we neutralized. So we have 0.096 moles of NaOH. We're just going to use one little fraction to do some dimensional analysis. Moles of NaOH on the bottom to cancel it out. And then we're going to put moles of the acid, H2SO4, on the top. Since we have moles and moles on the same fraction, where do we get the numbers from? Yeah, the chemical equation. The number in front of NaOH is 2. As H2SO4 is 1. So we just need to divide it by 2. If you notice, it's also the reverse of what we did here. And so the amount of acid that was in the flask was 0.048. That's the moles of acid. All right, and then last step, we just need to use the molarity formula again to calculate for the molarity of the acid. So we're going to plug in 0.048 moles of H2SO4 on the top. We're going to divide it by the volume of the acid, which was 150 milliliters, so 0.15 liters. We just need to divide in the calculator 0.048 divided by 0.15. And then our concentration for the acid and our final answer is 0.32 molarity H2SO4. Now, if you guys are able to do that on your own, that is really great. You will be fine on the exam. It's not going to be like the last exam where I pulled out that crazy stoic problem. It doesn't really get much harder than this. The hardest part is going to be like the balancing part. The numbers might be a little bit trickier, but this is as hard as it's going to get on your exam. So if you guys got it, good. If you guys didn't, totally good. You have this to refer back to, and we do have about a week till next Monday until we take the exam. Okay, so I'm going to leave that up there for a second, but does anyone have any questions about any of the 4 steps that we followed to find the concentration of the acid? All right, so hopefully it's not too bad. Make sure you guys have this as a reference because this is, again, what we're going to be doing in the lab next time that we meet. Okay, so with that being said, while you're going to copy that down, we're actually going to get started on part 1 of the lab. We said that we have to make that base, and that's what you're going to be doing today. You're going to be making your own base that you're going to be titrating into the acid. So just make sure that when we go over the instructions for the lab that you're very accurate and precise with it, because if your base concentration is messed up, you're going to get the wrong number for the acid concentration, even if you do the calculation correctly. Okay, so with that being said, let's go over the lab for today. So if you guys are not sitting next to your partner, make sure you guys go sit next to your partner. Let's pull out the lab procedure handout that I gave out to you guys. I know some of you guys, it might look really ugly. So if it is, you guys can go to Canvas. I have posted the handout for you to take a look at on your screen.
Princeton Worth, I just changed the cartridge.
Oh, did you really? That's okay.
Sure.
Yeah. Intro to Titration Lab.